Okay, and then this part's a little harder. You've got a base 7. Now 7 and x, the operator would be times. And then I have x to the second power, and then y to the third. I had to put a times operator here. And then that second power out here, you can't really see it that good because this printing paper is terrible. This second power, here, I'll put it here. That's a second power. That will need to be distributed to every single power that's here, okay? So my bases are just the factors, right? Your 7 times your x. Don't put the power on the x yet, times your y. And do that in this square here. Now, what you need to do is distribute that second power to each one of these. But the problem is 7 doesn't have a power. So we're going to put a 1 there. It's 7 to the first power. Now distribute your 2 to every power that's in there, okay, with the rainbows. That means times. So on the 7, we're going to be taking our 1 times 2. Because it'd be like 7 to the first power and then to the second power. So that's 1 times 2 is 2. Okay, and then my x. My x is to the second power, but it is surrounded by a parentheses, and everything in that parentheses is to the second power, so I take 2 times 2, and that's 4. And then the y, we're going to be taking 3 times 2, which is 6. Okay, pretty easy. Now, that's not the final answer. Okay, you got to do one more thing. 7 is a base, x is a base, y is a base. Circle the numerical base, not the variable bases. These are variables. You need to figure out what 7 to the second is. That means you clone 2 7s and multiply. That's 49. So this needs to change into a 49. Now the x to the 4th power stays x to the 4th because I don't know what number x is. Same with the y to the 6. I don't know what number the y to the y would be. Okay, and that's the answer. Okay, my next problem. 8 and x, that would be multiplication operation. So I put a dot, and then x to the second, y to the third. That would be a multiplication operation. Okay, so my bases, I have a base of 8, a base of x. 2 is not a base. 2 is a power on the x, and a base of y. Now, we need to figure out what exponents are going to go on these bases, okay? So that, remember, that 4 is distributed, so 4 to the 3, 4 to the 2, and since the 8 has no exponent, it automatically takes a 1. And then the 4 is distributed to the 1. Okay, so 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. Okay, not quite done because I have 8, x, and y. The base with the actual number, I need to figure out what that is. So 8 to the 4th would be 4 8s replicated and multiplied. It's not just 8 times 4. It's 8 times 8 times 8 times 8. That's too big of a number for me to know in my head. Okay, 4,096 times x to the 8th times y to the 12th. Because those are letters, they're variables, you don't know what number they are. Okay, next problem. I have a 4. 4 in the x, that's a multiplication operation, and then x to the second, y to the third, that's a multiplication operation. Okay, so I have my 4 times an x. The second power changes, so I don't want to put the second power times the y. Because all these belong to the 4th power belongs to all these, so the 4 has to be distributed to the 3, to the 2, and the 4 is to the 1 power. Don't forget that, okay? You need a little power. Don't distribute the 4 to the 4, because that's an exponent. That's a base. Okay, so 1 times 4 is 4. 2 times 4 is 8, and 3 times 4 is 12. Okay, now I have these 4, x, and y. The base that actually is a number, I need to figure that out. I need to replicate 4 4s and multiply them. 4 times 4 times 4 times 4 is 256. So this needs to be replaced with 256 times x to the 8th times y to the 12th. Okay, next. I got a 2x, that means 2 times x, and then x to the third and y to the second, that means times as well. So I have a base of 2, a base of x, and a base of y. Now again, 5 is distributed to 2, 5 is distributed to 3, but the 2 needs a power, so it's 1. Don't distribute the 5 to the actual 2. You don't distribute an exponent to a base, okay? You need an actual exponent to exponent, so you put a 1 there. Okay, so 1 times 5 is 5, 2's to the 5th, x 3 times 5 is 15, and then y 2 times 5 is 10. All right, now, these bases, this is the only one I would actually be able to figure out. Now, there is a way to figure this out on your calculator right away. 2 to the 5th power, instead of going 2 times 2 times 2 times 2 times 2, you hit 2. This power, this upside down V is your power button, okay? 2 to the 5th. I got 32, so I can replace this with 32 times x to the 15th times y to the 10th. Again, those are variables. We don't know what those are equal to, so you just leave them. Okay, next problem. I've got 3 times x and x the second times y. Remember, no operation means it's multiplication. So I have 3 multiplication x multiplication y. Now, this 4 belongs to everything in here. Well, the y doesn't have a power, so we put a 1 there and distribute the 4 to the 1. The x has a second power, so we distribute 4 to 2. And then the 3 has no power. Remember, don't ever distribute an exponent to the base, okay? I could see a lot of people doing that, but you put a 1, so you have an exponent to an exponent. So 1 times 4 is 4. 2 times 4 is 8. 1 times 4 is 4. Okay, 3 to the 4th. We can figure that one out. I can take 3 to the 4th power, and that's 81. So I can replace this 3 to the 4th with 81 times x to the 8th times y to the 4th. Okay, next problem, 7x, there'll be a multiplication operator, xy, there'll be a times operator, and these are powers. Okay, so I have 7 times x times y. Okay, so I distribute that 2 to the 4, that 2 to the 3, and the 7 needs an exponent. Again, don't distribute 2 to 7. I can't emphasize that enough, okay? You put a 1 there. So I distribute 2 to 1. So 2 times 1 is 2, 2 times 3 is 6, 2 times 4 is 8. Okay, I can figure that one out. That one's pretty easy. It's just 2 7s cloned, and that's 49. So I can replace that with 49 times x to the 6th power times base y to the 8th. Again, the variable bases you can't do anything about. You just leave them. Okay, 8xy, 8 times x, x times y. Okay, so I've got 8x and y. Now we got to figure out what exponent goes on these bases. Okay, the 3 needs to be distributed, but we need exponents with the y. So y is to the 1st, so I distribute 3 to 1. X is to the 1st, 3 to 1. And 8 is to the 1st, so 3 to 1. So 3 times 1 is 3, so all these will be 3. Again, 8 to the 3rd means 8 cloned 3 times multiplied, or you can go 8 power 3. Makes it go a little quicker, okay? So this is replaced with 512 times x to the 3rd times y to the 3rd. Okay, and then 2, so 2 and x, we'd put a multiplication operator. X and y, multiplication operator. So I have a 2 times an x times a y. Okay, so this 2, okay, so let's look at these. We need to distribute the 4 to the, but y needs a power, so it's 4 to 1. Well, we have a 3, so 4 to 3. And the 2 needs a power to distribute, so we put a first power, because 2 to the 1st and 2 mean the same thing. Okay, so 4 times 1 is 4. 4 times 3 is 12. 4 times 1 is 4. I figure that out, 2 to the 4th 16. X 12, y to the 4th.